Picture a storm so violent it tears modern roofs apart, floods streets in minutes, and leaves entire neighborhoods uninhabitable. Now picture medieval homes, built without steel frames, power tools, or weather forecasts, still standing after centuries of wind, snow, heat, and rain. This isn't romantic nostalgia. It's a quiet architectural truth we rarely confront. Medieval shelter was designed for extremes, not averages. And the reason we ignored those designs has less to do with progress and more to do with speed, cost, and forgetting what weather is capable of. Medieval people did not build homes expecting comfort first. They built shelters expecting punishment from nature. Storms were not rare events. Winters were not mild. Heat waves were not temporary inconveniences. Weather was assumed to be hostile, unpredictable, and relentless. That assumption shaped every decision, from where walls were placed to how roofs met the sky. One of the most fundamental medieval shelter principles was mass over lightness. Thick walls of stone, earth, mud brick, or timber framing filled with wattle and daub were not inefficient by accident. They were deliberate defenses against temperature extremes. Mass absorbs energy slowly. Heat takes hours to penetrate thick walls. Cold does the same. This meant medieval shelters didn't react instantly to weather. They resisted it. Modern lightweight construction reacts immediately, which is why indoor temperatures swing wildly during storms and heat waves. In cold climates, medieval shelters were compact and inward-facing. Small windows reduced heat loss. Entryways were indirect, often with turns or vestibules that prevented wind from blasting straight inside. Roofs were steep, not aesthetic. Snow slides off steep roofs instead of accumulating and collapsing structures. That same steepness shed rain quickly, reducing leaks long before waterproof membranes existed. In hot and dry climates, medieval shelters did the opposite. They spread inward around courtyards, creating shaded, protected microclimates. Exterior walls were often nearly blank, minimizing sun exposure. Openings faced inward, not outward. Heat was treated as an external enemy to be filtered slowly, not invited freely. This inward orientation is almost completely absent from modern housing, which prioritizes views and light over thermal survival. Another ignored principle was ground coupling. Medieval shelters often sat partially into the earth, not underground, but anchored. The ground maintains a relatively stable temperature year-round. By lowering floors even slightly, medieval builders gained natural insulation against both heat and cold. Modern homes elevate living spaces away from the earth, cutting themselves off from one of nature's most reliable thermal stabilizers. Roof design deserves special attention because medieval roofs were not just covers, they were weather systems. Thatch roofs, often dismissed as primitive, were incredibly effective insulators when properly maintained. Thick layers of reed or straw trapped air, resisted rain, and shed water rapidly. In cold climates, thatch kept heat in. In hot climates, it kept interiors cool. When damaged, it could be repaired locally without specialized materials. Modern roofs are thinner, more complex, and often fail catastrophically rather than gradually. Timber framing in medieval shelters was flexible by design. Wood bends, stone cracks. Medieval builders understood this intuitively. Frames absorbed wind stress instead of resisting it rigidly. This flexibility allowed buildings to survive storms and even earthquakes that would shatter brittle modern materials. The goal was not rigidity, it was forgiveness. Medieval shelters were also repair first, not replacement first. Materials were chosen because they could be fixed repeatedly. Cracks in earth walls were patched. Damaged beams were reinforced. Roof sections were replaced without dismantling entire structures. Modern construction favors materials that are fast to install but difficult to repair. When they fail completely. Orientation mattered as much as materials. Medieval homes were positioned with prevailing winds, seasonal sun paths, and local geography in mind. Cold winds were blocked, summer breezes were captured. Hills, trees, and neighboring buildings were used as shields. This was not accidental village chaos, it was accumulated climate knowledge encoded into settlement layout. Even interior layouts reflected extreme weather thinking. Sleeping areas were placed where temperatures were most stable. Storage rooms buffered living spaces from external walls. Hearths were centralized to distribute heat evenly rather than create hot and cold zones. Smoke paths were designed to draw air upward, improving ventilation without drafts. What we often mistake for cramped medieval living was actually thermal efficiency. Smaller spaces are easier to heat and cool. High ceilings were used strategically where heat needed to rise. Low ceilings were used where warmth needed to be conserved. Modern open-plan living sacrifices this control for aesthetics, then relies on machines to compensate. Perhaps the most important difference is failure behavior. When medieval shelters were overwhelmed by weather, they degraded slowly. Leaks appeared before collapse. Cold seeped in gradually. Occupants had time to adapt, repair, or relocate within the structure. Modern shelters often fail suddenly. Roofs tear off, walls flood, systems shut down, leaving no buffer between safety and exposure. We didn't abandon medieval shelter designs because they stopped working. We abandoned them because they didn't fit industrial priorities. Thick walls take space. Local materials require skill. Climate-specific design resists standardization. Uniform housing is easier to finance, insure, and mass-produce, even if it performs worse under extreme conditions. As climate extremes intensify, this forgotten logic becomes uncomfortable. Medieval shelters were not optimized for comfort on mild days, they were optimized for survival on the worst days. To truly grasp why medieval shelter designs handled extreme weather better than many modern buildings, we need to stop viewing them as isolated houses and start seeing them as environmental organisms, structures that evolved alongside climate, terrain, and seasonal violence. Medieval shelters were rarely designed as standalone objects, they were nested into landscapes. Hillsides were used to block prevailing winds, valleys were avoided for flood risk, forest edges were chosen for windbreaks and timber access. Villages clustered tightly not out of fear, but because shared walls and reduced surface exposure conserved heat and reduced storm damage. A single exposed house suffers more than a connected row. Medieval planners understood this intuitively. In flood-prone regions, medieval shelters adapted vertically instead of horizontally. Living spaces were raised above ground level. Ground floors were used for storage, animals, or workspaces expected to flood occasionally. This wasn't negligence, it was acceptance. Flooding was assumed. Damage was planned to be sacrificial, not catastrophic. When water receded, life resumed above. Modern buildings often place critical systems, electricity, heating, and plumbing at ground level, guaranteeing total failure during floods. In wind-heavy regions, medieval shelters avoided flat, wide faces. Roof lines were broken, staggered, or angled to deflect gusts. Rounded or irregular shapes reduced pressure points. Sharp corners were avoided where possible. Wind was not resisted head-on, it was redirected and softened. Modern box-like structures create massive pressure zones that fail suddenly when wind exceeds design limits. Another forgotten principle was material compatibility. Medieval builders chose materials that expanded, contracted, and aged at similar rates. Wood joined to wood, stone joined to stone. Lime mortar was softer than stone, allowing movement without cracking. Modern construction often combines incompatible materials, steel, concrete, and plastics, that expand differently, creating stress fractures that worsen under extreme weather. Fire, one of the most devastating medieval threats, also shaped shelter design. While medieval cities did burn, shelters themselves were designed to limit fire spread locally. Thick walls, earthen floors, and compartmentalized interiors slowed fire movement. Thatched moofs were often replaced or wetted during high-risk periods. Fire was treated as an environmental force, not a freak accident. Modern shelters often assume fire suppression systems will handle everything, until they don't.
Cold weather shelters reveal perhaps the starkest contrast. Medieval homes in harsh winters were not warm everywhere. They were warm where it mattered. Sleeping areas, food storage, and water sources were protected. Other spaces were allowed to remain cold. This zoning conserved fuel. Modern homes attempt uniform warmth, dramatically increasing energy demand and vulnerability when heating fails. Doors and windows were treated as weak points, not conveniences. Medieval windows were deep-set, shuttered, and small. Shutters were solid, not decorative. During storms, they were sealed completely. Glass was rare and precious, not assumed. Modern glass-heavy designs maximize exposure and then rely on technology to mitigate consequences. Even maintenance culture was part of shelter design. Medieval shelters expected constant small repairs. Cracks were patched early, roofs were inspected seasonally. Maintenance was normalized, not deferred. Modern shelters often hide damage until it becomes structural failure. What we interpret today as primitive living was often selective comfort. Medieval people didn't aim to control their entire environment. They aimed to control just enough of it to survive extremes. This restraint is exactly what made their shelters resilient.
As climate volatility increases, modern architecture is slowly rediscovering these ideas. Thick walls, earth integration, passive insulation, compartmentalization, but often without the behavioral systems that made them work. A medieval shelter without medieval habits is only half a solution. The most uncomfortable realization is this: medieval shelter design wasn't an early stage of modern architecture. It was a different philosophy entirely, one built around limits, endurance, and adaptation rather than dominance over nature. We ignored it not because it failed, but because it asked us to live differently. If we keep peeling this back, an even more uncomfortable layer appears. Medieval shelter design was not just about surviving weather. It was about surviving when weather destroyed everything else. Medieval builders assumed that extreme events would break systems, not just test them. Roads would wash out, supply lines would vanish, repairs would have to be done with whatever was already on hand. This assumption shaped shelters in ways modern construction almost never considers. One of the most critical design philosophies was material locality. Medieval shelters were built almost entirely from materials found within a short distance: earth, stone, timber, straw, lime. This meant that when storms damaged structures, repairs didn't depend on distant factories or specialized components. A wall cracked, soil and lime were available. Roof damaged, thatch could be replaced locally. Timber broken, nearby forests provided replacements. Shelter resilience was inseparable from supply independence. Modern buildings often survive only as long as external supply chains do. Once replacement parts or specialized labor disappear, damage becomes permanent. Medieval shelters assumed isolation and were built accordingly. Another overlooked principle was designed imperfection. Medieval shelters were not airtight, perfectly straight, or uniform. Gaps existed, materials breathed. These imperfections allowed structures to flex under stress. Wind passed through instead of pushing relentlessly. Moisture evaporated instead of being trapped. Modern construction aims for precision and sealing, which increases efficiency under normal conditions, but magnifies failure under extremes. Medieval builders also understood sacrificial elements. Not every part of a shelter was meant to survive equally. Roofs were designed to be replaced more often than walls. Exterior finishes weathered intentionally, protecting deeper layers. In floods, lower spaces absorbed damage to preserve upper living areas. This hierarchy of loss meant failure was controlled, not catastrophic. Modern shelters often lack sacrificial layers. When failure occurs, it tends to be total. Electrical systems ruined, walls destroyed, interiors contaminated. Medieval shelters degraded in layers, buying time and options. Settlement layout reinforced shelter resilience. Medieval villages clustered homes tightly, not just for defense, but for thermal and structural buffering. Shared walls reduced exposure to wind and cold. Fire spread was limited by thick dividing walls. Storm impact was distributed rather than concentrated.
Modern zoning separates structures, increasing exposure and resource demand during disasters. Another critical difference lies in water interaction. Medieval shelters were designed to tolerate moisture without collapsing. Lime-based mortars and plasters absorbed and released moisture naturally. Timber frames dried after storms without rotting. Floors were often earthen or stone, not sensitive to flooding. Modern materials often trap moisture, leading to mold, rot, and structural decay after extreme weather. This moisture tolerance is why many medieval buildings still stand after centuries of storms. They weren't waterproof, they were water-forgiving. Even smoke and fire management reflected extreme weather thinking. Medieval hearths and chimneys weren't just for warmth. They created vertical air movement that dried interiors after damp weather, reduced condensation, and improved air quality. Smoke-blackened beams were not signs of neglect. Smoke acted as a preservative against insects and decay. Modern interiors are sealed and sterile, then struggle with moisture and mold under stress. Perhaps most striking is how medieval shelters integrated human behavior into structural performance. People knew where to sit during heat, where to sleep during cold, where to store food during damp seasons. Shelters taught their occupants how to survive through layout and constraint. Modern shelters expect occupants to remain static while machines adapt the environment instead. This difference matters when machines fail. Medieval shelters were never comfortable everywhere at all times. They were comfortable enough in the right places at the right moments. This selective comfort conserved energy and materials. Modern shelters attempt universal comfort, creating dependence on continuous power and control. As extreme weather becomes more frequent, modern architecture is slowly relearning these lessons, but often stripping them of their cultural context. Thick walls without behavioral change don't work. Passive cooling without acceptance of slower rhythms fails. Medieval shelter was a partnership between building and inhabitant, not a service provided to passive occupants.